So we just learnt about universal law of gravitation. Why do we call this as universal law of gravitation? Because it is applied
Happens
every,
everywhere.
yes, it happens everywhere in the universe. And that universal law of gravitation, it just states that between any two masses, between any two masses, there will be force of attraction, right? There will be
Mm.
force of attraction. So let us say the two masses are m1 and m2 and they are separated by a distance, say d, then the force between them will be given by the expression g m1 m2 by r square. But this was just the complete force which we have obtained. But if I have to describe universal law of gravitation, let's suppose in the examination, if we have to describe, we will just say the force between the two masses is directly proportional to the product of the two masses and inversely proportional to the square of the distance separating them, right? Square of the distance separating them. Okay, let us see some of the properties of this universal law of gravitation. So can I say that the force between the two objects, since it's depending inversely as square of distance, so we will say that this universal law of gravitation, it obeys inverse square law. Why do we call it as inverse square law, obeying inverse square law? Because it obeys, first of all, inverse variation as well as square of that inverse variation. This is just an add-on information. So we will just keep this in mind. Later on in higher classes, it will help us. Okay, let us do a simple problem from this universal law of gravitation, and quickly we will head on to the motion under gravity. So first question, let us suppose two objects are there. These two objects are having the masses 2 kg and 4 kg, let's suppose, and they are spaced at a distance. They are spaced at a distance 2
No,
meters.
sir, 1 minute, 1 minute.
Yes. So the problem was two objects are there, each of masses 2 kg and 4 kg. They are separated by a distance 2 meters. And let us suppose these two masses are brought closer by 1 meter. So you have to find out the force now. So let us say it is 2d meters, it is 1d meter. So what is the force now? The distance of separation between them is 2d. So what will be the force? We have the very first expression for the force according to universal law of gravitation, g m1 m2 by r square. So F will be equal to, let us say it is F1 because I am finding the force in first situation, and that will be G. What is M1? It is 2. M2 is 4, so it will be 2 into 4 by square of the distance. So it will be 2D whole square, and that should be 8G by 4D square, and that will be 2G by D square. Now let us find the force in this case, second case. So that will be G m1 m2, that is 2 into 4 by r square, that is the distance square. So distance is just d meters, so it will be d square. So that will be 8g by d square. And if we look, the first force, it was 2g by d square. So can I say that this 8g by d square, I can write it as 4 into 2g by d square, and I can say that it is 4 into f1. So overall, what I have observed that when the distance is decreased by half, the force becomes 4 times because it is inversely proportional to the square.